So in this video I will be explaining what the wall crawler is in terms of design and how its artificial intelligence is programmed. Its artificial intelligence is both programmed, the foundation of it rather, is programmed in C++, and the other behavior is then extrapolated to blueprints, and everything design related is done there. So before actually explaining what the source code and what the blueprints do, I think it's only fair to first show what the wall crawler does and explain its design in action. So here I am in the wall crawler arena rather, and I'll play the game. So as the player, you're mainly around, and there's this wall crawler that is jumping from wall to wall, and we can progress as the player, so obviously we need to defeat this enemy in some way or form. So let's say what is happening. I have a beam and I have a shield. So maybe, and it jumps based on the location of the beam player. So maybe if I lure it towards me, maybe I can do something with that. The wall crawler is defeated, and the door should open. At least that's the idea. So, if that wasn't clear what was actually happening, I will explain it more in detail, or in a more controlled environment. So, the wall crawler is a mini-boss within Defendyourfriend, and the players have to defeat this in order to progress further into the game, rather. So this is where the players start and enter the arena, and this is where they eventually get out of it once they've defeated the mini-boss in this arena. So at first, the basic design, or AI rather, of the wall crawler is that it jumps from wall to wall. I should actually bring up my other screens here. It jumps from, let's see if that's actually, that should be better. So the main AI of the wall crawler is that it jumps from wall to wall. So there are 4 walls here, and it is able to jump from wall to wall. Now, this is the only thing that is done in C++ as opposed in regards to its artificial intelligence. Everything else related to stunning it, shooting its legs, defeating it, and actually closing off the arena and such, and then opening the arena once it's defeated, that is all, and all the visual effects and such, that is all done in blueprints. But as the players, the main concept of the wall crawler is that you have to stun it in order to shoot all of its 6 legs that are designated by these red rectangles, or bars rather. In its normal behavior or behavioral pattern, the wall crawler will jump from wall to wall based on the location of the beam player. There are 2 players in Defendyourfriend, and it is based on the location of the beam player. So if the beam, for demo purposes, I will use this cube. The beam player is right here, and the shield player is this sphere. Actually, let's reverse that. This is the beam player, and this is the shield player. Now, as the beam player, let's actually put this on the right axis. The wall crawler jumps from any of these walls, any of these 4 walls, which I can set in here, the eligible walls. And what this does is it basically is a spline-based system which allows the wall crawler to jump to any point within these vector points, essentially. And based on these vector points, it is calculated how much distance is between them, which creates a spline, and on any point on that spline the wall crawler is able to jump. So the wall crawler would be able to, if it's on the top wall, as is the case right now, it is able to be over here, it's able to be over here, it's even able to be over here, but it can be over here. That's not possible unless I, of course, change the actual vector point. And the same applies to everything that is, or all the walls, essentially. If the wall crawler, if the beam player is within the proximity of the wall crawler, then it will jump towards the beam player. The wall crawler will jump towards the beam player, but it won't actually follow the beam player. It will track the position of the beam player and then will jump towards the nearest wall that it is on. So in this case it would go from here to perhaps this wall, or maybe the bottom wall, but for now, for demo purposes, it's going to be right over here. And if the beam player was, for example, all the way over here, then the wall crawler would of course jump towards this wall, and it would be and so on. And that's essentially the main, the foundation of this AI, to make everything else work. And it's the only thing that is done within C++, which is done over here. I will bring up the screen a bit more. Actually, let me enlarge this. Okay, so this is what everything that is related to the jumping, as I explained earlier. So on begin play, we create an array of these walls, which are the vector points, as I pointed out earlier. The vector points right here. And based on that, we calculate whether or not it is able to jump on any of these. These are all public variables, which means that they can be changed, or the values can be adjusted within the editor. Let's see. This is all legacy. So once the beam player actually let's explain the design a bit more first. So you as the beam player, the beam player is essentially the target point of the wall crawler, or rather the element of the AI which allows the wall crawler to jump to any of these purple splines rather. The main idea of the shield player in this boss fight is that it has to get in between the beam and the shield player while it is jumping. So on its way that the wall crawler is jumping towards one wall, the beam or the shield player has to use its shield ability, and if that is true, then the wall crawler is considered to be stunned. And what does stunning mean? It means that it will continue its path towards the wall that it was going towards, and it will stay in this position. In normal circumstances, the wall crawler will land on its legs. Will land on its legs like this, and it will jump towards a wall like this, and then rotate itself smoothly to land correctly on its wall. But in the case that it is stunned by the shield player, and it is shield or stunned midair, it will continue its path until it reaches its intended wall rather, and it will stay like this. The reason why I designed it this way is to make sure that for the next step of the boss fight, which is you as the beam player have to shoot the 6 walls or 6 legs, all of its 6 legs, in order to defeat it. And the red bars over here are essentially 3D widgets that essentially act as health bars. They deplete the more the wall or the beam player is hitting or shooting its beam towards or on one of these legs. And I will show you. I will show later how that is all regulated. So there are two main things here. There's a state machine that is acting here. So there is a state which is called idle, and there is a state which is called jumping, and that is the main aspect that is done in C++. There is a state called idle, which is when it is just sitting on a wall like this, and when it is jumping from one wall to the other wall, and that is considered the state that we call jumping. Now, this is all done by C++, as I mentioned. There is some legacy code here, but essentially this is where the idle system is defined. So there is a game state which we call a Defendyourfriend game state, and essentially what this does is it gets all the information on the characters. So that will be the Defendyourfriend character, which is subdivided into a class for the BP shield player and one for the BP beam character. It is targeting, as I mentioned earlier, it is targeting the beam player in order to make the wall crawler eligible to jump towards any of these walls. To any of these walls. And there's then the jump state, which essentially gets the distance between the wall that the wall crawler is currently on. It then gets the jump speed, or the speed at which it should go to the next wall, and that is all based on the position of the beam player. So essentially what is happening here is, if the beam player is over here, it gets the position of the beam player. It gets the position of the beam player, or the wall crawler gets the position of the beam player, and then based on that, whether or not it's in range, it will go towards the wall that it is nearest to. And then internally or implicitly we define this as the state of is jumping, which we will use later to do a lot more things in blueprints. This is all legacy. We don't really use these anymore. Is hit jump to random. Yes. So there's one more thing that is crucial in C++, which is the random jump chance, which is essentially, normally the wall crawler is only able to jump if the beam player is in range, and then it also depends on the position of the beam player where the wall crawler will jump towards, as I explained earlier. But sometimes we want to randomize that chance. So instead of the position of the beam player being sort of the aspect that makes the wall crawler jump towards the wall, sometimes we want to define, we want to discard that, and we just want to make the wall crawler jump not based on the beam player position. So instead of the beam player being over here and the wall crawler going towards the beam player and then to the nearest wall, with this class, rather, this void, a wall crawler jump to random, it is possible that instead of it going to the beam player, this beam player right here, and then to the nearest wall, it is able to be over here, for example, or it can be at the bottom of the wall. It can be at the bottom of the wall. And this was done just to create a bit more randomness in the fight, but it is also mainly a way to compensate for the wall crawler not always getting the right wall. Even though it should most of the time, it sometimes does not. And the random chance to, or jump to random, is a way to kind of compensate for that. And then obviously we define this in the C++ code as well. And that is essentially everything that is related to the source code, and everything else is done in blueprints from this point on. So I'm going to enlarge the blueprints. There are two things to the way the wall crawler is defined within blueprints. One is in the level blueprint, and the other is in its actual actor class. Let's start off with the logic of the wall crawler, which is essentially the most interesting part. Let's see if it's still in the frame. Alright, so there are a few things about the logic of the wall crawler. First, let's start off with the health. Or should we? No, let's first start with the actual stun state. So there's the way the players stun the wall crawler. Within the actor class, there is a sphere volume, trigger volume, which is right over here. And what the shield player has to do is the shield player has to use its shield and overlap with this sphere trigger volume in order to stun it. But it can only be done if the wall crawler is actually jumping. So if it's currently, if it is just sitting on the wall right here, it's just sitting on the wall, then obviously it cannot be stunned. So we need to define that as well. Actually, I should probably change this. I think that should be better. Right, so instead of the wall crawler being able to be stunned while it's idle, just sitting there, there needs to be some sort of a risk for both of the players by actually having to lure it out, sort of. And what this does is essentially that. So on begin overlap with the stun area, which is the sphere trigger volume over here, we need to cast a ray towards the actual ability of the shield player, which is this actual shield, and there's a class for that called the My Player Shield. So we cast a ray towards the My Player Shield, and if that cast returns true, or if the cast succeeded, then we first need to make sure that the wall crawler is actually stunned. But we also need to make sure that it is not already stunned, because if it's already stunned, then obviously we don't want the wall crawler to be stunned again. So the first check here is a boolean called isStunned, and this essentially checks whether or not it's actually already stunned. In case the wall crawler is already stunned, then it returns a string called the wall crawler is already stunned, so nothing is executed after this. And it is crucial that this check, or sanity or safety check rather, is here, because otherwise everything else will essentially break. So this first check will almost always be or will return false. But in case it is true, then obviously don't stun it again, because that's all done over here. So if the wall crawler is not already stunned, then we can execute the actual stun state. These are we create a sequence so we can do multiple things at once. Usually you want to use this for a tick-based event, but in terms of organizing blueprints, this is a slightly better way to work. But this has everything to do with the vibration for both of the players. If they're using a controller to provide some player feedback as to, okay, if the wall crawler is stunned, then the controller vibrates. It's mainly a way to provide some player feedback, and also the audio component that is played once it is actually stunned. But, and here's some more feedback related to changing the material of the skeletal mesh, which gives more visual feedback as to when the wall crawler has been hit by the shield and therefore be stunned. Here's some more visual feedback in terms of a slow motion effect when it's actually hit. It gives the player some more time to realize what has happened. And then we set the material again. But this is when we actually implicitly say, okay, from this point the wall crawler has actually been stunned. So from this point on, we can say the wall crawler is officially in the stun state. So once it has reached this part and the player tries to stun it again, or perhaps this cast has triggered multiple times, then it will return true, which means that this will no longer be executed. So from here there are a few variables that we define. There's some more player feedback with the stun duration. Now the stun duration is really how many seconds, or for how much time does the player or the wall crawler actually is it in the stun state. And what does the stun state mean? It essentially means that if the wall crawler has been stunned and it is on a wall, on any wall, and it is stunned, then it cannot do anything, which gives the players some time to actually shoot the legs, which is the ultimate goal of the wall crawler boss fight. Here's some more visual or audible feedback regarding the sound effects. But the main thing that we're doing here is we make sure that the wall crawler is not able to jump anymore if it is in the stun state. So there's a value or a variable called recovery time after jump, which is the time that it takes for the wall crawler to, if it has reached its target, to how much time is in between the wall crawler reaching its target and then being able to jump again. And essentially what we're doing here is during that stun duration, we essentially the recovery time after jump is more or is greater than the stun duration, or is greater or equal to the stun duration, which in this case the stun duration is 12 seconds and the recovery time after jump is 10 seconds. Now that may not seem logical, but we do some stuff later which makes that more that makes it more logical rather. So what it does here is, if the wall crawler has reached the wall and it has been stunned, then it cannot do anything for a 10 seconds period. During its stun duration, it is not able to jump for 10 seconds really. These are some printed strings to help us debug whether or not the wall crawler has been in the stun state. And after that we do another setting of a value called recovery time after jump, and this time it's 4 seconds. So in total there is a so after this stun duration has been completed, which is 12 seconds, then it takes 4 seconds for the wall crawler to be able to jump again. So the wall crawler jumps towards one target, it has been stunned and hit by the shield, so it continues its path towards its original target goal. And then for 10 seconds it's not able to do anything. Now after those 10 seconds we essentially say, okay, well, it's no longer in the stun state, but it still takes 4 seconds for the wall crawler to actually do anything. So in total, if it has been hit by the shield, which means it is in the stun state, it will continue its path towards its original target, and it cannot do anything for 14 seconds. And during that time the players are able, or the beam player rather, is able to use its beam and shoot these 6 legs, or at least some of them, because obviously we don't want the beam player to do this in one go. The idea is that the beam player or the wall crawler has to be stunned multiple times in order to actually defeat it. And after that we change the material of the wall crawler back to its original material, so it gives more visual feedback in terms of when the wall crawler is in its stun state and when it is not. This is all legacy right here, but it's a boolean really, which is called spawn drill enemies on stun. This is more of a prototype at the moment, but essentially what it does is, if the wall crawler has been hit by the shield player, or the shield rather, then with this bool we can toggle whether or not it should spawn another enemy called the drill enemies, where the wall based on the position of the wall crawler. This is still in the prototype phase, but it is in there. We might actually replace this with rocket launchers at some point, but this has to be play tested. But that is essentially it for the stun logic, really. Now, in terms of, this is all debug, that's not really necessary. This is all legacy, but I keep it here in case we need some of these nodes. The damage system. Yeah, I can explain this fairly quickly. So the damage system, essentially, it's what it currently is if the beam player or the shield player overlaps with this area. Maybe I can show this in a... Yes. So here's the wall crawler. Here are its legs. Here are its spikes, which are danger, which is dangerous for the players. And essentially, what we do is we do a couple of things, or at least I do a couple of things. First of all, if the beam player and the shield player overlap, and this is what the current state of it, but if the beam player and the shield player overlap with this area, and the shield player is not using the shield, in other words, for whatever reason the shield player is not able to stun it, then the players die. And what happens when the players die, it essentially sets them back towards this area, which means that there's a laser going from here to here, and a laser here to here. There's a double-sided laser. There's a door over here, and it's sort of a small puzzle that the players have to solve in order to get back into the fight right here. And this puzzle works in 3 ways. It is able to be solved if the beam player is over here and the shield player is outside. It is solvable if the shield player is inside and the beam player is outside. It is also possible to solve this if the beam player and the shield player are both inside. This will be revised at some point. I'm currently working on a different system that sort of defeats the players, but this is the current situation. So we basically, these areas are called the damage areas, over here and over here, which are again box trigger volumes in this case. But over here we essentially check whether or not the shield, the my player shield, which is the shield of the shield character, we essentially cast a ray towards that player shield, and if that is true, then we set a boolean, and we call that shield is used, and we will use that later to actually define whether or not we should execute some code or whether we should not execute some code. If the beam player or the shield player is using the shield and it's leaving that dangerous area, then we set that boolean to false. So what it does here is it casts a ray towards the shield character and the beam character. Now if the shield is used in this case, so in other words that ray cast to the shield was successful and we set this boolean to shield is used, then we know for sure that the player is actually using the shield. In other words, it's stunned. And if it's stunned, then the player shouldn't be able to be killed by the wall crawler. If they're not using the shield, then the player should be killed by the beam or the wall crawler. So it's what it's doing right here. It is casting a ray towards the shield character, but it only does so if the shield is not used. So if the shield is not used, then we cast a ray towards the BP shield character, and if that is successful, then we do a final check and check whether or not the wall crawler is actually stunned, which is again, we get the boolean that we defined over here, is stunned. And this is more of a safety check, but you cannot be too sure here. So we cast a ray towards the shield character. If that is successful, then it will execute towards this branch. And if it is stunned, then obviously don't do anything. But if it's not stunned, then the shield player should die at this point. Because the shield is not used, we do a final check to see whether or not the shield or the wall crawler is actually stunned. If it is, then that is fine. Then don't do anything further with regards to this. But if the shield is not used and we do a final check to see whether or not the wall crawler is actually stunned, if it's not, then we set the actor location, which brings the shield player to this location, and it sets the beam player to this location right here. And this is sort of the simulated death system within Defendyourfriend. The reason why I did it like this for this fight is, first of all, we want to change the death system because it's all based on checkpoints right now, but that system is not in, so I had to sort of simulate that system in here. So that is what the death system is for the wall crawler at this point regarding the players. I'm going to revise this at some point where the wall crawler or one of the players actually has to be in between or close in between a wall like this and the wall crawler, and if that is true, then only defeat the players. But that will be done at a later point in time. But that's everything regarding the damage/death system currently. This is all legacy. This had to do with the shockwave, but since we cut that feature from the boss fight because it was too complex and its behavior was very inconsistent. But basically what it did was, while it jumped, or if it's reached its target, one of these walls, and the beam player or the players were far enough from the wall crawler, then it would spawn a shockwave from this wall towards the other wall and then bounce back towards the original wall. And what that did was it sort of created a system where the wall crawler, or the shield player rather, had to block the shockwave, which means that the beam player had to get behind the shield player in order to protect themselves, because the spawn or the shockwave was dangerous and that would kill the players if they were hit by it. And because the death system in Defend Your Friend is binary, the players are either alive or they are dead. So this is the system for hitting the legs of the wall crawler, which is the main goal that the players are trying to achieve here. If the wall crawler is stunned, then the beam player is eligible to shoot its 6 legs, and once all these 6 legs have been destroyed, the fight is over, and the doors will open over here, and the players will be able to progress further into the game. So first, let's define this. There is an event which is called Hit by Beam, and this is all based on the API of the of Defendyourfriend. This is a, let's say, a general event. So this is an event that can be called from to any blueprint rather, which allows us to do a lot of which allows us to extrapolate that within the blueprints. So here there's an event, and this is all done by the event itself is done by C++, which is something that I did not work on, but the event itself is callable to blueprints. The only thing that I did do, however, is create a boolean to check whether or not it's friendly or not. But that is another aspect of it. So the event Hit by Beam is when the beam of the beam player is hitting anything, and literally anything that it is hitting, because it's essentially a raycast. But because we want to use this for a specific object, which are the legs, we need to define the components. We need to have a variable here, in this case it's a primitive or U primitive component, because these are cubes. because of programmer art. So we make sure that we get a reference towards all of these 6 legs, which have been called left leg side, or leg left side middle, leg right side outer, and such. And we just make sure that the component that we are referencing is the same as the component that we're hitting with the beam. And if that is true, we need another boolean over here, or a branch rather, or rather we need to make sure that the beam that is actually hitting it is the same as the friendly beam. There are two, this is what some of the programmers did. There's only one sort of laser object within the game, which are the red lasers and the blue beam. And the blue beam is essentially the same as a laser, but it has a boolean which makes it friendly. And this is what is done over here. So if this component is the same as the component that we're actually hitting, and if that is true, we also need to check if the beam is actually friendly. Then we can execute all of this other stuff, which is related to actually depleting the health bars over here and actually destroying it. But currently we are getting a bit ahead of ourselves. Yeah, okay, so this is all related to actually the health system of the legs. So these red bars are essentially widgets, and what it essentially is doing is saying, okay, we have a progress bar over here, we send a percentage, and we divide that by 100. Because the way these widgets work in, I can probably show this, BP wall color, or wall color health rather. Yeah, so what this does is it's a widget blueprint, and we set this to a progress bar. And what a progress bar does, it is essentially a float that goes from 1 or 0 to 1, with 1 being the max and 0 being the minimum of the bar. What we're doing over here is essentially dividing that by 0. So what we do is we divide it by 100,